Welcome to Brain Vision.
In this problem, we're going to be looking at two experiments involving polarizers. In the first one, we have a couple of polarizers set up. The first one, we'll call that theta 0. It's just oriented vertically. And the second one is tilted at an angle theta equals 60 degrees. And we have unpolarized light coming through here. So light's just scattered in all directions. And after it hits the polarizer, then it's going to be polarized along that transmission axis. So it starts off with some initial intensity, travels through those polarizers, and it'll have some intensity when it comes out the other side. That's experiment 1. Experiment 2, set up very similarly. We also have two polarizers. The first one being theta equals 0 degrees. But the second one now is tilted an unknown number of degrees from the vertical. So we're not sure what this theta is yet. But we do know that the light coming in experiment 2 is already polarized. It's polarized along the transmission axis of the first polarizer. It has the same intensity as in experiment 1, but now it just has to be polarized before it reaches that first polarizer. And so what we want to do is figure out what will this theta be in experiment 2 so that the intensity coming through both polarizers in this experiment will just be the same as in experiment 1. So let's figure out what that intensity is for experiment 1. It's got an intensity S0 of unpolarized light. After it passes through the polarizer, that intensity is now going to be 1/2 of what its initial intensity was. And that's true regardless of what theta is, just because unpolarized light, always half of it will get through the polarizer, the other half will not. So the intensity, 1/2 the initial intensity, is now incident on the second polarizer. Here it does matter what that angle theta is, because our polarized light will reduce in intensity relative to that change in the transmission angle. And that's based on Malice's law, which you may recall is the intensity is equal to initial intensity times cosine squared theta, where theta is the relative difference in the transmission angles. So if we go ahead and plug in theta equals 60 degrees, like we know, S0 times cosine squared of 60. I know that cosine 60 degrees is just 1/2. So squaring it, cosine squared of 60 is 1/4. Sorry, I lost my 1/2 here. This is 1/2 the initial intensity, because that's what was incident on the second polarizer, just half of what we started with. So now we have 1/2 the initial intensity, and we know that cosine squared 60 is 1/4. So the intensity leaving the polarizers in experiment 1 is equal to 1/2 times 1/4 times the initial intensity, or just 1/8 of its initial intensity. That's how much actually gets through both polarizers. And that's what we want to set up in experiment 2. We need angle theta to be whatever it needs to be so that 1/8 of the intensity gets through. Well, let's follow it along its process and see how we'll set that up. It comes in already polarized, so after it passes through the first polarizer, its intensity does not change because it's already lined up exactly the way it needs to be. So all of its intensity gets through. So now, incident on the second polarizer is the full intensity, S0, and using Malice's law, we'll see that S equals S naught cosine squared theta. Thetas are unknown, but we want this S here to be equal to 1/8 of the original intensity like we found in experiment 1. So let's substitute that in, 1/8 of the initial intensity. And that's going to be equal to S naught cosine squared theta. You see that the S naughts cancel each other out. So we just get that cosine squared theta equals 1/8. Can take the square root of both sides now. Cosine theta equals 1 over square root of 8. And then finally, we want to take the cosine inverse of both sides. Sine inverse of both sides. And you'll see then that theta is equal to the cosine inverse of 1 over square root of 8, which is about 69.3 degrees. So now our question is asking how many additional degrees does the second analyzer have to be rotated? Well, when we compare that to the first one, 60 degrees and 69.3 degrees, we're going from 60 degrees, 69.3 degrees. The additional degrees that needs to be rotated, additional rotation of 9.3 degrees. Now, does theta need to be increased or decreased by that additional amount? I would say increase because it's going to a larger theta from 60 to the larger number of 69.3.